what you just saw there is an example of inertia. But what is inertia? Well, inertia is the first law of motion by Isaac Newton, who's one of the most influential scientists in the scientific revolution. Inertia states an object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction unless acted upon by unbalanced force. But what is unbalanced force? To understand what it is, you must first know that force is a vector quantity, meaning that it has both magnitude and direction. This force results from an interaction between objects. In a free body diagram, we can see the different forces that can act on an object. The arrows in this diagram show the direction of the force. The downwards arrow from the apple shows the force of the gravity pulling the apple down, while the upwards arrow shows the normal force exerted by the table's surface to counteract the force of gravity. As both of these forces balance each other with equal magnitudes and opposite directions, the apple is in equilibrium and stays in the current state of motion, which is basically not moving at all. Then, an unbalanced force comes in. As the wind coming from the side starts to apply force on the apple, the inertia of the apple resists this, but in the end changes its resting state to a sideways movement because of the wind's force. This force is then the unbalanced force, as there is no equivalent force acting on the other side of the apple. The unbalanced force therefore causes acceleration, which is the change in velocity. The apple resting on the table from a velocity of 0 changes its movement due to the wind's presence. Now let's consider this example. As the car moves, the driver also moves. Now suddenly, there is a rubber duck and a huge rock obstructing the road. Don't ask why, just roll with it. The driver suddenly steps on the brake to stop the car. The sudden change in state in motion shows inertia as the driver continues to move in his seat as the car stops. In order to stop the driver from continuing to move forward, his seatbelt holds him in place as the car stops. Here's another example. Removing the rubber duck out of the road? Easy. Removing the heavy rock out of the road? Yeah, it's pretty impossible. This is because the rock has a larger mass than the duck. This means that the rock has a larger inertia, so it has more capability to resist our change in motion, in which a driver cannot produce enough force to counter it. This part of the situation shows that mass is directly proportional to inertia. So the larger the mass, the larger the inertia, and the harder it is for an object state of motion to change. Tower cranes and construction sites are another example for the use of inertia. In order to lift the large and heavy materials for a building, heavy machinery is used in order to counter the large resistance, also known as inertia, of these items. Practical applications of inertia such as these are contributing to society. Just make sure you're trained to use a crane first. Overall, the amount of inertia an object has is directly related to its amount of mass. Inertia is an object's resistance to change to its current state of motion. A change, such as through acceleration, is caused by an unbalanced force. Without this unbalanced force, an object can continue to stay in its current state of motion on and 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 on.